Last time, we found the kink that lets a neural network bend a straight line into any curve it wants. But we quietly skipped over the strangest part. A network only does math. It only eats numbers, and language is made of words. So before any of that machinery can fire, something has to turn a word like king into numbers a machine can actually compute on. Here is the part that should stop you cold. Nobody ever told the computer that a queen is a female king. It worked that out by itself, just from reading. And by the end of this video, you will be able to prove it, with arithmetic, by walking an arrow across the space inside the machine. Here is the promise. By the end, you will understand the single trick that turns words into geometry. You will see why distance in this space means similarity, why a direction in this space means a relationship, and why you can literally add and subtract words like numbers. This is the front door of every large language model, the very first thing ChatGPT does to anything you type. Get this one idea, and attention, the thing everyone talks about, finally becomes thinkable. So let's open that door. Start with the wall. You cannot feed the word king into a matrix multiply. A matrix multiply wants numbers, and king is letters. The whole season has hiddenness, because every input so far was already numeric. The little ball rolling downhill, the grids of pixels, all numbers. But the moment you want a network to read, you smack into the oldest problem in the field. We need a number for king. The only question is, which number? First instinct. Just number the dictionary. Cat is 1, dog is 2, apple is 3, all the way down. Clean, simple, and quietly broken. Because now the numbers carry accidents. Dog being 2 implies it is somehow twice cat. Banana sitting next to apple in the alphabet implies they are neighbors in meaning, which they are not. The order in a dictionary has nothing to do with what words mean. We smuggled in fake relationships just by counting. Okay, second instinct, and it is cleverer. Give every word its own switch. Make a list 50,000 slots long, all zeros, except a single one in the slot for this word. This is called a one-hot vector, and it is beautifully honest. No word is secretly bigger than another, but now swing the other way into a new problem. Every word is now exactly the same distance from every other word. Cat and kitten are as far apart as cat and Tuesday. It records identity and it records zero similarity. We threw the meaning out entirely. So here is the fix, and it is the whole episode in one sentence. Instead of one giant switch, give each word a short list of numbers, not 50,000, a few hundred, or in the biggest models, a few thousand. And here is the radical move. Do not choose those numbers yourself. Let the network learn them. That short-learned list of numbers is called an embedding. And what those numbers turn into during training is the magic we are chasing. Picture it as a giant lookup table, one row per word in the vocabulary. Each row is that word's list of numbers, and every row has the same width, the same length of list. When the model meets a word, it does one thing. It grabs that word's row, token in, row out. That row is the word's vector. The whole embedding is just this table, and remember the spine of this whole season, it is all weights. This table is more learned weights, no different in kind from the ones inside a neuron. Now the part people skip, and it matters more than anything. This table starts as pure random noise. Nobody fills it in. Nobody writes royalty in column 7 or gender in column 12. At the start, it is garbage, and the meaning we're about to find is not in there yet. So where does it come from? The exact same place everything in this season comes from. The ball rolling downhill, gradient descent, the predict, blame, nudge loop. As the model gets better at predicting text, it slowly nudges every one of these numbers, and structure falls out as a side effect. And these tables get enormous. In GPT-3, the vocabulary is about 50,000 tokens, and each one gets a list over 12,000 numbers long. Multiply those out, and the embedding table alone holds about 617 million numbers. Sit with that. Before the model reasons, before it writes a single word, it spends hundreds of millions of values on just one question. What does each word mean? In smaller models, it is even more lopsided. Around a third of the entire network can be this one dictionary. Here is the pivot that changes everything. Stop reading the row as a list of numbers and start reading it as a place. 2 numbers is a point on a page. 3 numbers is a point floating in a room. Keep going. 12,000 numbers is a point in a space we cannot picture, but, and this is the key, we can still measure inside it. We can ask how far apart 2 points are. We can ask which direction one points from another. Numbers just became geometry. Welcome to the galaxy of meaning. And once words are places, watch what training does to the room. After enough reading, similar words drift together. The animals end up huddled in one corner. Countries gather somewhere else. Verbs pull off on their own. Nobody sorted them. The network was only ever trying to predict text, and words that get used in the same kinds of sentences slid into the same neighborhood, because that was the cheapest way to predict them. So, the first rule of this space is simple and beautiful. Distance is similarity. Close together means used alike. One quick tool before the magic, because attention will reuse it later, so plant it now. When we ask how similar two words are, we usually do not measure raw distance. We measure the angle between our two arrows. Point the same way, and they are deeply related. Point at right angles, and they have nothing to do with each other. Point opposite, and they are near opposites. Think of it as an alignment meter. We care which way a word points, not how long its arrow happens to be. Keep that meter in mind. It comes back. Now the hard part. This is the step that trips everyone, so go slow with me, because it is also the coolest idea in the entire video. It is not just that similar words sit near each other. It is that relationships in this space are consistent directions. The same relationship is the same arrow everywhere. Give me 60 seconds and this snaps into place, and once it does, you will see why you can do math on words. Look at 3 arrows, from man to woman, from king to queen, from uncle to aunt. Do not look at where they start. Look at how they point. They are roughly parallel and roughly the same length. There is no single point in this space labeled gender. Instead, there is a gender direction, a bearing you can travel in, starting from anywhere. It is exactly like a real map, where go north means the same thing whether you start in Paris or in Tokyo. The relationship is not a place, it is a direction. And it is not a one-off. Cat to cats, dog to dogs point along a shared plurality direction. France to Paris, Japan to Tokyo point along a shared capital of direction. Each kind of relationship has its own consistent bearing across the whole space. So why on earth would the arrows line up this neatly? Because the network was only trying to predict text, and king and queen show up in nearly identical sentences except for gender. The cheapest way to store both is one shared base, plus one shared gender shift. Reusing a direction means fewer numbers to learn, which means lower error. The geometry is efficient, so the ball rolling downhill found it on its own. And the instant relationships are directions, arithmetic stops being magic and starts being obvious. King minus man plus woman is not a spell. Read it as a walk, start at king. Subtract the man direction, stripping away the maleness, and you are left with something like pure royalty. Now add the woman direction. You are not conjuring a word. You are just walking along a consistent arrow and seeing where you land. So let's take the walk honestly. Start the arrow at king, travel backward along the gender direction, then travel forward along it. And the point you land on sits right next to queen. Nobody wrote that rule. No human said a queen is a female king. It fell out of a pile of random numbers being nudged toward predicting text. The relationship is real enough that you can compute your way to it. That is the moment that should give you chills. But now let me be honest in a way most explainers are not, because the honesty is what makes it real. The arrow does not land exactly on queen. It lands in the neighborhood. Look at the true ranked results. Queen does come out on top, but monarch, throne, and princess are right on its heels. Queen is the nearest, not a perfect bullseye, because in real text, queen means more than just a female king. It is a chess piece, a band, a card. The messy result is the honest result, and honestly, the fact that it gets this close at all is more impressive than a clean trick would be. And here is the detail almost nobody admits. To get queen, you have to throw out the words you started with. If you do not remove king, man, and woman from the search, the closest point to king minus man plus woman is, embarrassingly, king itself. You barely moved from where you began. Every slick demo silently deletes the input words first. Knowing that does not ruin the trick. It is what separates understanding the geometry from being fooled by a magic show. And it is not one lucky example. Researchers built benchmarks of tens of thousands of these analogy questions and let pure vector arithmetic answer them. France is to Paris as Japan is to what? Walk to walking as swim is to what? And it gets a sizable fraction right just by adding and subtracting directions. Not perfect, not a parlor trick. A real, measurable signal that meaning really did become geometry. Take a breath here because we just climbed the hardest hill in the video and the view is good. Now the turn because the same idea has a shadow. If gender is a direction, you can ask the machine other analogies along it. Man is to computer programmer as woman is to what? Run it on embeddings trained from real human text, and the answer that comes back is homemaker. Father is to doctor as mother is to nurse. Nobody coded those stereotypes in. The geometry simply recorded the patterns in everything we have ever written, prejudice included. Meaning is a direction. And so, it turns out, is bias. And this is not a lab curiosity, because these vectors sit upstream of real systems. Semantic search, recommendations, resume screeners, they all work by ranking things by closeness in exactly this kind of space. So a biased space quietly becomes biased rankings, biased suggestions, biased filtering, with nobody intending it. The magic and the danger are not two different things. They are the exact same machinery. Meaning is a direction, and so is prejudice, and the model cannot tell them apart. That is the part worth remembering. Quick myth to kill before we move on, because it is the most common one. People imagine each number in the list means one clean thing. Column 1 is gender, column 2 is size, column 3 is royalty. Almost never true. The gender direction we found is not a single column. It is a blend of many of them, a direction we discovered after training, not a label anyone assigned. Most of the raw numbers on their own mean nothing you could name. The meaning lives in directions through the space, not in the individual axes. And now, the twist that breaks our own toy, which is exactly why it is the way forward. Everything so far gave each word one fixed vector. But take the word bank. Riverbank and savings bank are completely different ideas wearing the same 4 letters. A fixed vector cannot be both. It would have to sit in one spot, blurring 2 meanings into a smudge. So a single frozen point per word cannot be the final answer. The real models do something smarter. In a real model like GPT, the embedding is only the starting guess. The word bank walks in with one vector, the lookup we built. Then, every layer afterward moves that vector based on the words around it. Sitting next to river, it drifts one way. Sitting next to money, it drifts the other. By the time it leaves, the 2 banks live in completely different places. Static picture we drew is the intuition. Vectors that shift with context are the reality, and that shifting has a name we have been circling all season. So let's close the loop we opened. A network cannot read a word, so we hand each word a short, learned list of numbers, and embedding. That list is a place in a high-dimensional space. Space, distance is similarity, near means used alike. And direction is meaning, the same relationship is the same arrow everywhere. That is why king minus man plus woman lands you next to queen, an analogy nobody ever taught the machine. It discovered it, because geometry was the cheapest way to predict our words. And that is the proof I promised you at the start, not a definition, a walk. You can take king, subtract a direction, add another, and arrive near queen. We turn the dictionary into a map and meaning into a place you can travel to. But sit with the bigger thought it leaves behind. If king minus man plus woman really lands on queen, then a model that could read a whole sentence's worth of these vectors and let them talk to each other could actually understand it. Which raises the only question that matters next. How would words even talk to each other? That is attention, and it is exactly where we go next.